This is part 14 in a series of videos in which I'm attempting to repair and restore a Wren executive computer system. This is not actually it. I now have a second unit that I'm repairing for someone. The one that we've looked at previously is actually this one. So if you have been watching this series of videos that I posted on this machine, you'll know that in the last video I was having an issue with the floppy drive controller chip. I couldn't get it to read a sector from the floppy disk drive, and I suspected it was a faulty floppy drive controller, but I couldn't find one anywhere. I finally managed to get hold of one. As I say, I now have two of these machines, and I'm hoping that it's not the same issue with the other machine. I haven't opened that one up yet. I will do that entirely on camera, but for this one I wanted to get the floppy drive system working. So as I say, I found an old machine that had a device in it I could use. It's not from a Wren, it was from an old computer card that I found, and luckily the floppy drive device on that card worked. The machine still wouldn't read a sector from the floppy drive. I had another failed IC, and I've replaced that, and it appears now that it is capable of reading a sector from the floppy drive. So I'll get the scope on, and then we'll get a floppy disk in the drive and try reading it and see if we get any activity. So apologies for not getting the repair of the board on camera. I realised that this series was getting a bit long, and I didn't want to bore you with too many details of fault finding. Once I'd got the replacement floppy drive IC plugged in, it didn't take long to track down the issue, but fundamentally it wasn't citing data. The glue logic between the floppy drive and the control chip itself wasn't working. That was just a buffer chip. I've replaced the buffer chip, replaced the floppy drive controller. I've also adjusted the pot. If you recall, the pot had failed, it was open circuit. Each of these devices needs to be individually set up for the board that it's on. The pot sets the voltage threshold level for the internal data slicer within the floppy drive controller chip. If you want to see how that's set up, then leave a comment, but there's a test mode you can put the floppy drive control chip into, and then you can just adjust that pot to give the right results. It's very simple to do. It's fairly boring, so I didn't bother videoing it. But now the system should be able to read a sector from a floppy disk. So I've got a floppy disk in the drive. As I've mentioned before, I don't put the actual system disk in the drive until I'm fairly confident that the system as a whole is working at pretty much as it should. So what I've got in the drive at the moment is one of the utility disks that comes with the Wren. It won't boot from that disk, but it should still be able to read the first sector. The boot will fail because it's the wrong disk, but we should see activity on the scope screen. So what the scope's looking at as ever is the DRQ line on the floppy drive controller chip. Each time the floppy drive interface successfully decodes data byte, that line changes state, and the processor is triggered with an interrupt, and it reads the data byte, resets the floppy drive DRQ line, and then the process repeats until all the data bytes from the disk sector have been read. So in other words, when I power up the Wren, we should see a series of pulses on the scope that show that it's reading data bytes successfully from the drive. So I'll power up the Wren now, goes through its self-test, and then it should try to access the floppy drive. And there we can see it's accessing data. Doesn't boot, of course, because it's the wrong disk. I'll reset the Wren so we can see it attempting to read the disk again. And there we have again the pulses showing that it's successfully reading data bytes. And it will do that every time. It's reliable. I've been through the same process with this that I went through with the Mimi 802 and 803. So if you've seen those videos, then what I do is attach a logic analyzer to the board, and then I capture the data I've disassembled the ROM code, so I know what to be looking for in the data. And I can be fairly confident it's trying at least to read the correct sector from the disk. So what I'll do now is put the actual boot disk in, and we'll see how far that goes. So this should be a boot disk for this machine. Pop that into the drive, close the drive door, and I'll now reset the MIMI, and it should read the first sector. That should contain the bootstrap loader for the system, and it should then start loading the system from floppy disk. So the drive is now spinning, but unfortunately you can see nothing's appearing on the scope. So we'll try it again. I'm not sure if you can see enough of the screen, but it's giving us a message on the screen that's saying that it's not able to read the disk. It's not saying the disk isn't there, it's just saying that it can't read it. So there's obviously something going on here that we need to investigate further. Now, I no longer believe there are any more faults, at least not with regard to the booting of this machine with the machine itself. I think the issue now is with the disk itself. Very similar to an issue I'm having with the MIMIs that I'm currently working on. So to investigate this further, rather than attaching the logic analyzer, which you've seen me do before, what I'll do instead is I'll break out the CryoFlux, which is a low-level reader for floppy drives, and we'll see what that can make of the disks, both this one and the one that we tried earlier that could be read. So this is one of the methods I use for trying to recover data from potentially damaged floppy drives. This particular one is called CryoFlux, but I have a few different ones that I use for various different tasks. This particular one's fairly simple, and all it really does is it allows a PC to talk to and control various different types of floppy drive, and it can do reads right down to the flux level on the drive itself, so it can read, record and write individual flux transitions on a floppy drive, and that's providing of course the disk isn't too badly damaged. I do have other systems I use, but this is the simplest one, so we'll try this first. We'll start with the disk that the Wren itself was able to read, and this is the one that would toggle the DRQ line, so the Wren machine could actually read this disk successfully. So put that into the drive. As usual, I'll put the interface for the software up in the corner of the screen, and I'll just move the CryoFlux system across so that we can see the entire drive. Okay, so what I've got the software set up to do is read an MFM sector image. So in this case what it's going to do is try to use the formatting information in the headers on the floppy disk to try to figure out where the data should be on the disk surface. It's then going to try and read it, and it will put that data, if it can read it, into a file on the PC. The interface for CryoFlux is fairly simple. Each of the blocks in these windows represents one sector on each side of the floppy disk. This is a two-sided disk, and depending on whether it's successful in reading each sector, it will color code each block, and what we're looking for really is a green in each of these squares. It's 40 tracks per side on this particular disk, so that's what I've told it to stop reading at once it gets there. So we'll give the file a name, and now we'll try to start the drive. We should see the drive start up, and we should see it progressing through and reading each sector and track in turn. And we can see on the software it's alternating sides. So as you can see, it's only reading data from one side of the disk, and it's obvious why it's doing that. If we look at the drive, you can see it's only a single-sided disk. But CryoFlux is smart enough to figure that out, and that's why on the software we're seeing one side, that's side 1, which is the second side, that's the side facing us on the drive. There's nothing being read from that side simply because there is no head on the drive. but the side that does contain data so far is showing all greens, as it should, so that's looking quite promising, and we're nearly at the end, and that has successfully read the entire disk. If we now look at the file that's been created, I'll just open that. It will appear to contain garbage. It is, of course, just raw data that's on the drive, but the fact that it's there and that it was able to read each of the sectors, and as far as CryoFlux is concerned, each sector was correct. That is, each sector that it read matched the header information that it was expecting to see. So it would read the header, and the header would tell it where the data should be and what it should be, and as long as the data was actually present and didn't contain any errors, then CryoFlux flagged that particular sector as good. What I'll do now is swap this disk for the one that the Wren couldn't read. So this disk seems fine, and this is the operating system disk that we had an issue with. We'll pop that into the drive, close the door, and I'll give the file a new name, and we'll try reading the disk. So far it's not happy with the first three sectors. The first two it kind of read, but had to modify to make sense of them. The third one on side 0, it's flagged as bad. So in other words, it's just not at all happy with this disk. On side 0, it's now starting to read some of the sectors. Has a problem with sector 5, and the rest now seem to be reading. Now unfortunately the operating system, at least the bootstrap loader, is in the first few sectors, and so we can now see why the Wren is struggling to boot from this disk. Having examined the disk under a microscope, I'm not at all surprised. There's a lot of physical damage to it. It looks like it was more likely just left in the machine for years on end, and the disk itself has degraded. What I'll do is I'll try reading the disk in other ways. I can do raw flux reads using this system. I have another system I can try using to try to recover the data. I don't hold out a lot of hope, judging from the state of the disk, but I'll give it a go. But if I can get this disk recovered, then hopefully I can finally get the Wren to boot. But I believe now the Wren itself is actually working. Any comments are welcome, and if anyone has a copy of the Wren boot disk or an image of the Wren boot disk, I'd very much appreciate it.